Hello and welcome to the presentation of the new features for Vissim and Viswalk 2024. I guess many of you already have had the chance to follow such a presentation at one of our user group meetings. The release has been in last autumn. Also at the YouTube channel or on our website, we have presented highlight features. So this is in a way the conclusion of the release communications, which shows a reference of new features presenting all of them or almost all of them. I want to begin in an unconventional way, namely directly going to sources for further information. Just to not miss that, this presentation will be detailed in a way, but not to the level of detail that you could go, particularly if you need a feature urgently in a project which you are doing. Then you can, of course, contact our regional representatives. You find the contact addresses on our webpage. If you want to begin a discussion with the entire Vissim community, go and check out the Vissim forum at LinkedIn if you are not already a member there. And of course, the single source reference source of new features is the What's New PDF, which is installed with Vissim. So there you find really every new feature which is presented here. Here is an overview of the new features. I mean, you can categorize them in various ways, either saying that's a Vissim feature, that's a Viswalk feature, and this one is for both. Another way would be to categorize more, that's the back end, that's the front end, editing, simulation, internals, externals, and a data model. Maybe this second categorization is the better one, at least I like it better because categorization is clearer in a way. I've built this presentation such that the features with the strongest visuals, probably also where you are tempted most to play around with, I have them at the end. So as an incentive to stick with this presentation until the very end. So no surprise, the first features are more formal stuff, namely that some external components have been upgraded. So good to know, but not a lot to talk about that. Then, feature is almost underestimated. It's been quite some effort to do that, which took also longer than the last release cycle. That's the re-engineering of the pedestrian simulation of Viswalk, the internal routines. You don't see a lot of that. Therefore, it's at the beginning of this presentation. So why did we put a lot of effort into stuff which you don't see? At least you don't see it right away. There were many triggers, many motivations. I'm stating here just two of them because they are very concrete. Maybe you remember that a couple of years ago we introduced formulas and then user-defined attributes and attribute modifications and attribute decisions. And these features which change the values of attributes, somewhere in the data model, somewhere in the simulation, they are very powerful. They make Viswalk much more flexible. But there was one problem when you use them together with multi-threading, so parallel simulation, parallelization of the simulation. And that's that the simulation was not necessarily reproducible anymore because the attribute modification could just jump in, take a value of an attribute of, let's say, a pedestrian, which was treated in a different thread, change it and put it back, and with the same random seed value in the next execution of the simulation. This happened just at a slightly different time, so it wasn't synchronized explicitly, and that could change the course of the simulation, and reproducibility was gone. And of course, we want to have multi-threading and reproducibility and formulas with attribute modifications. With this re-engineering, it's restored. Now you can have all three of them at the same time and not only two at the same time. And then it was also sometimes a bit difficult to explain when which conditions or states of motion were computed, and that has been formalized with this re-engineering as well. So what has been introduced in our source code is a formal and strict layer of activities. So if you want, now our pedestrians are aware of what they are doing, what kind of walking, of moving they are executing currently, and that helps to, how should I say, to handle the simulation internally, and to restore the reproducibility with the hyper-threading or multi-threading. It was also necessary to introduce a strict and fine-grained sub-time step ordering. The result is that it's not only possible now again to do multi-threading with reproducibility combined, but the multi-threading is now also more efficient and faster. So the fine-grained subtime steps, they induce an overhead of computation, but the multi-threading is more efficient. So for Viswalk, it's now the case that when you simulate with one core, depending on the simulation model, clearly, but it may be that it's a bit slower even. But the more and more cores you have, the more the version 24 is superior in terms of computation speed over previous versions of Viswalk. Now, the second point is what I already mentioned. The reproducible use of formulas in multi-threaded runs. And we hope for that future development will be quicker and more stable. And our experience so far is that this is indeed the case. So there are some ideas for future development where we thought previously that will be a lot of effort, which now appear to be much less cumbersome for development. Now, signal control. Again, the second re-engineering topic in this development cycle was for Vissig, signalization, signal control. Why? We needed it to bring it to Linux. Doing so, the re-engineering, we did not only do the minimum, but fixed some issues which we detected along the way. So meaning fixed some bugs and improved some stuff, which also helped the use of Vissig with or under Windows, if you want. So, but the main point is that Vissig fixed time signal control is now available also in Linux. Then something which will be most interesting for Northern American traffic signal times planners, and that's the RBC enhancement. So there is now transit priority, preemption, leading pedestrian intervals, and vehicle omits. So how should I say? It's probably second level use of RBC. So beyond the basics. So we added some stuff here as well. Now, different to RBC improvements. Here is something which everyone will be interested in, and that's that Vissim, the vehicle simulation, is faster. How much faster, you will ask, and that depends heavily on the model. What you see here is performance improvements when you simulate multi-threaded, so only one core at a time. That's nowadays quite how should I say, theoretic or hypothetical thing to do, that you're not making use of multi-threading, but you see that there is a model which is 3 times as fast now, and all models which we tested were at least 20% faster. Now, the multi-threading, there maybe the most interesting thing is that previously you see there was very quickly, when you added threads or added cores to the computation, there was quickly a saturation. So it didn't help a lot going beyond 4, at maximum 5 cores, even 3 cores was close to the maximum. And now you see, I mean, the scaling is not linear, obviously. It cannot really be linear. But you see that up to 20 cores, it helps a little bit. Every thread you add helps at least a little bit, even going from 19 to 20 cores. One remark here. While we did that, or in the year before we did that, Intel introduced the hybrid core architecture. So Intel processors nowadays, they have some performance cores and some efficiency cores. And there, of course, when you when you're already making use of all of the performance cores, adding efficiency cores doesn't help so much as adding performance cores before. Yeah. So if you really measure simulation speed in detail, you will see effects from core architecture in your results as well. But when you don't measure the time, probably you won't feel a lot. And it's mostly important, say, when you have a very large model which uses a large part of RAM and is scaling efficiently in multi-threading, and you want to use the computer for working as well. When you have a computer which is anyway there only for the simulation and not used at the same time for anything else, then use all of the cores. It doesn't get worse, usually at least. But when you have such a CPU with hybrid architecture and you want to do simulations, maybe even multiple simulations, and at the same time continue working, it might be in certain cases clever to not use all of the cores for your simulations. Yeah, so here you see this case where we almost had 8 times as fast simulation as previously, and all of the runs where all of the models were executed at least with 80% enhanced speed. Display speed was also improved. That's of course something which helps only as long as the model is small, because when the simulation effort is already large, the time which is consumed for visualizing the simulation and the model is insignificant anyway. But sometimes in the initial stages of doing a project, or for small scale, maybe calibration projects, it's quite interesting that it now almost doesn't make a difference if you follow the simulation visually or go to quick mode. So as you see here, there is in 2023, this small model with only one link and a few cars could go with visualization in 2D up to 15 times real-time speed. And now it's up to more than 400 times real-time speed. And you see here the recording, the frames per second of the recording is too small to display any vehicle twice. So each frame shows a completely whole new set of vehicles, and you don't see any motion at all. It looks just like random colors. Good. We're going more and more towards colors and to what you are actually working with, how Vissim is displaying to you as a user. GUI and editing. Here is one thing that can be very interesting and helpful from time to time, that now you can multi-select vehicle routes and edit them all together. So you see here that an intermediate point was introduced for 3 routes at once. That's a feature. In this case, we introduced it first for pedestrians, for vehicles, for pedestrians in Viswalk, and added it now also for the vehicles. So similarly, of course, for public transport lines, here are 2 bus lines, and we want to make both lines stop at this stop here, and you see that this can now be done at once, not having to do the work twice. Good. The labels were revised. The handling, as well as the data model. Before, only route decisions could have labels. Now, route decisions and routes can have labels. And for pedestrians, also the intermediate points of routes can have their own labels. If it makes sense to use all 3 of them at the same time, that's up to you to decide. You can do that. You don't have to choose between them. And you see that it's not only that there are now labels which haven't been there before, but there is also more options to configure the labels. So, I mean, you could choose the attribute which is to be used for the labeling before, but now there is also a color scheme. So say if you are color coding the vehicles by speed or by acceleration, you can now make the label have the same color. And the same for pedestrians. Pedestrians didn't have labels in 2D before. In 3D, you could give them a 3D information sign one by one. So for each pedestrian, you had to define the information sign. We have to define it individually. Now in 2D, you can activate the label for all pedestrians at once. You can choose if it should be the number of the pedestrian or the speed or any other attribute, and also the color coding, including the background color, which can also be partly transparent. Yeah, of course, this can be interesting for presenting a model as much as it can be helpful for debugging. One more labeling item, which I'm sure many of you will like very much, and that is that now conflict areas have a dedicated labeling, which is referred to in the context menu when you set the priority. Before that was partly guessing, because it was you had to choose link 1 has the right of way. Oh, which one is link 1? And now it's visualized A and B, and you can choose these in the context menu. And that's maybe visually the smallest improvement, but it can also be very helpful, namely that the routes now have midway indicators, which is the direction of the route. So when you're zooming in and you don't see the entire route with the red dot and the blue dot, but you only see the yellow line. Before you couldn't see, is it going from here to there or from there to here? And now you can see that with the help of this triangle. That one is maybe the issue which has will have the highest usage. Autosave backup copy that you can, yeah, I mean, don't have to explain it. Huh? Yeah, as you see here, it's configured each 10 minutes. A backup copy of the model is saved in a custom folder, so either in the modeling folder or in a combined backup copy folder. And if Vissim crashes, this catches your work from falling into the void. Visuals. We received many requests. Oh, your 3D models, they look a bit outdated. Can't you modernize them? That was tougher to organize than you would think, because where can we get models which we are allowed to include in our setup and distribute with anyone who wants to have a Vissim, even just a demo version? That was a matter of the business model. But then we found someone supplying these models who agreed to this. And you see some models were updated just as they have been updated in reality, Golf 5 to Golf 8. There are also new models which haven't been there before. And yeah, additional, how should I say, vehicle segments, maybe a pickup, a sprinter, a double-decker bus, and so on. So even here you see with interior furniture included for visualization. It's not only a matter of visualization. I mean, everyone is aware cars are getting bigger, and so are the new models in 2024. With the weighted average, the standard, the default model distribution of vehicles now has 11 centimeters longer vehicles. And as you see here, that means that for about 50 cars, you get one additional car length in the queue. So here you see 50 cars with the 2023 model distribution and 50 cars with the 2024 model distribution, and 50 cars is sufficient for the stochastics that you have the weighted average length of vehicles. And so therefore queues in front of traffic signals or anywhere will take more space. The outflow, the discharge rate will probably as well be affected, but there is more stochastic effect such that from one discharge, you usually wouldn't see that. So you would have to do many discharges and have a larger statistics to find that. But for the queue length, if you compare, you can see it with one glimpse of the eye. And please, the 2023 here means version 2023 and version 2024. It doesn't mean that from 2023 to 2024 cars in reality got that much bigger. So just in case someone is using this part of the video and posting it somewhere. One more visual thing, we have enhanced pavement marking. So first we have expanded the set of pavement markers which are which Vissim brings, and you can select from these, and then there is an option to have a user-defined pavement marking, which is a graphics file. You can paint, yeah, like here, could paint some cycling race stuff on the ground, or any other custom marker, and maybe just a reminder that what's the name of the software, or your company logo could be there, or a URL could be placed on the ground. Stuff like that can be light-handedly integrated into the videos which you are producing. Data model. First, the visual part of data model, the colorful part of data model enhancement is that there is now a data type color, which can be quite helpful. You're predefining some colors and then you're assigning it depending on some rules using maybe attribute modifications, or just for your later use in Vissim to color something. And that is combined with another new feature, namely that we have a new function color, where you can compute this hardly intuitive integer value for colors, which is always negative, and has on the large part of the numbers, I think it's the blue value and then the green and then the red, and it's very bizarre. And you just can calculate it now. So you have the red value, green value, blue value, all from 0 to 255, and the transparency level. And then this integer value is computed internally from these, and the color is applied wherever you apply it in Vissim. So that should stop a lot of the confusion which we had with that before. You already could edit colors, but which numbers to be used. You don't get these integer values here, which you need to implement the color which you want to see. Then that might be the most powerful feature we have in this release, which you tend to forget. Because it has not really visuals coming with it, or very decent visuals. And that is that now from any object in Vissim, you have a relation to the network settings. And from the network settings, you have a relation back to each and any object which we have in Vissim and Viswalk, or object type. So that's how it looks. So this is the list of attributes of the network settings. And since there is now relations from network settings to any object type, which we have in Vissim Viswalk, we can omit the settings from network settings. It's now the network. Yeah? That's what is implied, adding these relations, that the network settings become the network. And you see that there is now these relations to the 2D model distributions, to the areas, even to the aliases, conflict areas, anything, any object type, which you can think of, there is a relation. And that means, of course, that you can go from areas to conflict areas with the help of these relations. And it means that where previously maybe you had to define, say, when you wanted to have a constant value, say here a color, to be used with areas, it would have been defined with each area, and it was saved with each area, and it was in the memory with each area. And now you can just define such constants with the network and access the value from any object, which can be quite helpful and can ease the work. So where previously you had maybe complicated formulas, which were not easy to get, let's say for an auditor, that's now easier. And for that reason, because the network is now the central point, which has relations from anywhere and to anywhere, there is this eye of providence symbol on the slide. Good. Simulation, zipper merging. Zipper merging is not what you see here. That's just simulation, zipper merging. The zipper merging has been added to the driving behavior, namely the lane change behavior. as a new optional aspect. And it means, in a nutshell, that under certain conditions, a driver would consider a vehicle on the neighboring lane as if it was on the same lane for their own braking or accelerating. Zipper merging functionality can only lead to braking. So it would, in a certain situation, in a certain moment, only lead to cars slowing down. But for the system as a whole, it can mean that to a small degree, at least, the flow is enhanced. So the system as a whole is faster. But that's not guaranteed, because it's more complex when you use it than it sounds when I describe it in a nutshell. Let's look at a first simulation. So here we see, sorry, that's the wrong ordering. So here we have no zipper merging, and here we have zipper merging. And on, let's say, not the macroscopic level, but almost macroscopic level, what you saw before, when the capacity was used, or the capacity was insufficient on an on-ramp, then you had the queue occurring on the on-ramp. And now with the zipper merging and cars on the main direction slowing down to create gaps for the vehicles on the on-ramp, the spillback is more distributed on both. When you look on the zipper merging variant below, you might think, but it's not fully efficient how the drivers are behaving here. Yeah, the yellow ones are those who are in zipper merging driving state, or zipper merging interaction state. But yeah, zipper merging in reality is also not always efficient. People are slowing down too much, which can mean that capacity is actually reduced. It's not necessarily enhanced in every moment. Or they are not able to agree until the end of the lane, which would mean that even with zipper merging, it can happen that cars come to a standstill at the end of the queue, or at the end of the on-ramp, and so on and so on. The point is that in detail, going beyond the nutshell, more parameters are involved than just looking to the neighboring lane. First of all, there is, that's what you see here, a minimum speed which is set. So if a car is slower than that, they will stop doing zipper merging. That is to prevent a total breakdown of the flow. Second, drivers only do zipper merging when they are within the lane change distance, and that is a distribution. So it can mean that one driver is already, let's say, ready to do zipper merging, another driver is not, and that can already produce some hassle. The minimum speed is the same for all cars, for all drivers who have the same driving behavior. But for example, you could have different driving behaviors for HGVs and cars, different minimum speeds. You could have different behavior, let's say, for autonomous cars or driving assisted cars. And that could also mean that there is some cars who are zipper merging, others which are doing not, and those who are doing in a way they would expect others to do it, as it is in reality. I mean, we've all experienced it if we are drivers ourselves. So therefore, to really see the effect, I've prepared a model which most clearly shows the effect of the zipper merging, and that is when you first have a stretch of the road where changing lane is forbidden, that's here, and then it's allowed on a relatively short stretch of the road. And the lane change distance is the same for all of the drivers, and that's here where lane change planning, let's say, begins. So, and from that point on, as you see, when you've watched the video for some time, cars start zipper merging. And also important, the speed variance is not very wide. So I've used the same distribution of desired speeds for cars and HGVs here. And the demand must be under capacity. I mean, not too small, then zipper merging is not relevant as well. But when you have really clearly over capacity demand, zipper merging doesn't change a lot. You will just see a queue evolving. But when you're, I don't know, 80% of capacity with demand, 70%, then you can see these effects. And you see that here the cars just aim at being in the middle of the gap between two cars on the other lane. And nothing like that happens here where zipper merging is switched off. I've tried, that was the last thing I did in preparation for this presentation. I've tried different minimum speeds for this example, only this example. And there I found that, in fact, there is an effect on capacity. And that here, with using the standard 50 kilometers per hour speed distribution, the 40 kilometers per hour minimum speed for zipper merging produced the highest capacity, and the 10 kilometers per hour minimum speed produced the smallest capacity as an average of 10 simulation runs, while the default of 20 kilometers per hour minimum speed for zipper merging was very close to not using zipper merging. I'm not sure if the same picture persists if I have a distribution of lane change distances. Yeah? That might change things completely already. And what you see here, the demand here is the demand which so that the video stems from this part at the time 7,200 seconds, where anyway the capacity is still almost the same for all of the cases. So I would have had to record a video at higher capacity, at higher demands, and see if you can see with the naked eye that one case has a higher capacity than the other in one and the same simulation run without having to rely on simulation averages. Yeah, as you see, an interesting playing field and a feature to get accustomed to, which might take some time. But I think it's a good improvement of Vissim, and I wish you a lot of fun, and I hope that we might see at one of the upcoming user group meetings, which will soon be announced. And we're already looking forward to the next release next autumn. Thank you. Goodbye.